Okay, now let's discuss the applications of systems of equations. And one big application, you'll see it in business quite a bit, is called the break-even point. And the break-even point is when a business is not making money, but is not losing money. So in business, we have something called revenue, and that is the amount of money that comes into the business. And then the cost of whatever it is that you're trying to make and sell, that is the amount that leaves the business. So when you're making a profit, that means the revenue is going to be more than the cost. When you're losing money, that means the cost is going to be more than the revenue. When you're breaking even, the cost is equal to the revenue and your profit is 0. So when your profit is 0, or you can say the revenue is equal to the cost, that's when you have your break even. In this example, we have information about the cost of running a restaurant, and then we also have information about the amount of money that's coming into the restaurant based on the price of the meals. So we want to set up equations for cost and revenue. Then what we'll do is we'll use the substitution method to set them equal to each other and then solve for your variable. In this case, the question is asking, after how many meals does the restaurant break even? Whatever they're asking you to find, that's what you want to set equal to your variable. So my variable x is going to be the number of meals. So for my revenue function, that's the money that comes into the restaurant, and it says that they're selling each meal for $30. So every time they sell a meal, they're making $30. So if I want to find how much money is coming into the restaurant, I take 30 times the number of meals that they serve. So my revenue function is going to be 30x, 30 times x. Now my cost function is going to be how much money they have to spend to run the restaurant. Now it tells us in the problem that they have to pay a flat fee of $180,000. That's some fixed cost. Plus, it costs them $15 to make every meal. So that's 15 times x. So for every meal, if they make 2 meals, then it's going to cost them $30 because I take 15 times x. And then plus the fixed cost. So I have my revenue and my cost function set up. Now we're going to use substitution to solve. So I'm going to take this whole thing here, because we're saying it's when the revenue is equal to the cost, and plug it into revenue. So I have 180,000 plus 15x is equal to 30x. Now I'm going to solve for x, which will tell me the number of meals I need to break even. So I'm going to subtract 15 from both sides. So that gives me 15x is equal to 180,000. And when I divide both sides by 15, I get 12,000. So this is telling me if the business sells 12,000 meals, they will break even. If they sell more than 12,000, that's when they're going to start to make a profit. If they sell less than 12,000, that's when they're going to be that's when their cost is going to be more, so they're not going to be making a profit, they're going to be losing money. Now, if we look at this graphically, if I graph the revenue function, these are linear functions, even though I don't have it in there, it's a plus 0, it's mx plus b. I cross at the origin, and I have a slope of 30. So just a rough sketch, it's going to look like this. So there's my revenue function. I'll do my cost function in blue. So I cross at 180,000 on the y-axis, and my slope is 15. So it's going to be a smaller slope than the revenue. So it's going to look something like this. is going to cross at 180,000. And where they cross is going to be my solution. So this would be at 12,000 meals if we looked at this graphically. Okay, in example 2, it says find two numbers whose sum is 23 and difference is 11. So I have two numbers. Again, we have to label what everything is. Let x be the first number. Let y be the second number. We have to come up with, since we have two variables that we're solving for, we need at least two equations to solve. So it says that the sum of the two numbers is 23. So if I take x plus y, that should give me 23. It says the difference of the two numbers is 11. So if I take the difference of them, that's going to give me 11. Now this one is set up nicely to use elimination method, which is my preference. On the exam, unless the question says specifically how to solve it, you can solve it using substitution or elimination method. So this one's already set up though for elimination, because if you look, if I add vertically as it is, my y's disappear. So I'm going to use elimination method. So if I add my two x's, that's going to give me 2x. The y's disappear because I have a plus y and a minus y. And when I add 23 and 11, that's going to give me a 34. And now I can continue solving for x. If I divide both sides by 2, that's going to give me x is 17. So my first number is 17. Now to find my second number, I'm going to plug it back into one of my equations. It doesn't matter which one. I'll use the first equation. So that's going to be 17 plus y is equal to 23. I'm going to subtract 17 from both sides, and I get y is 6. So my two numbers are 17 and 6. And if we look back at what the question is telling us, we can double check to make sure it works. It says if I add the two numbers, I get 23. So if I take 17 and 6, I get 23. But the difference is 11. If I take 17 minus 6, I get 11. So this works. Okay, third and last example. This is a mixture problem, and if you've had chemistry before, you've probably seen something like this. It's asking us to mix two different solutions to come up with a new solution. So I like to draw pictures to visualize what's going on. So let's assume, if I had great artistic skills, that this is some bucket. And we're going to pour two different solutions into the bucket to create a new solution. The two solutions that we're going to add into the bucket, we have an 8% solution and a 2% solution. And when I add them together, I want to end up with a 3% solution. It also tells us that I want to end up with 24 gallons. It's asking us how much of each solution. So as soon as I look at that last sentence and it's asking me what I should figure out, what I'm looking for, then I know how to set up my variables. It says how much of each solution. So I need to find the number of gallons of each solution. So I'm going to set up x is going to be the number of gallons of 2%, and y is going to be the number of gallons of 8%. And again, I'm figuring out what my variable should be because I'm reading the question and it's asking me to find the number of gallons of each solution. So that's how I know to set up my variables. Okay, now I have to set up my system of equations. So I know I want to end up with 24 gallons at the end. So right off the bat, I can come up with an equation. X plus y is equal to 24. If I add the number of gallons of 2% and the number of gallons of 8%, I want to end up with 24 gallons. Okay, now for my second equation, this is where the percentages come in. I want 2% of X gallons, and I want 8% of Y gallons to give me 3% of 24 gallons. So now I have my system of equations. If I multiply this out, if I take 0.03 times 24, that gives me 0.72. So I can actually rewrite my equation so that it's equal to 0.72 if I want. And this is because I got 0.03 times 24. Okay, so now I have a system of equations. So what I want to do for this example is practice the app that I showed you, the simultaneous equation solver. So get your calculator out and go into that app, and we're going to put in our coefficients into the matrix. So our coefficients across the first row would be 1, 1, 24. Then the coefficients for the second equation would be 0.02, 0.08, and 0.72. And then I'll hit the graph button to hit solve. And what I'm going to find out is that the calculator gives me X is 20 gallons and Y is 4 gallons. So then our final answer would be, we're going to have 20 gallons of the 2% solution because X represented the gallons of 2% solution. And Y is 4, and Y was the gallons of the 8% solution. So I would have 4 gallons of the 8% solution. And when I mix those together, that's going to give me my 3% of the 24 gallons. Now, typically on an exam, I usually give you one system of equations that you have to solve by hand and one system of equations that you can use your calculator for. So when I want you to use your calculator to solve it, I will specifically say in the question you can use your calculator to solve. So the majority of your points when you're using your calculator to solve will come from the setup. I'm going to expect to see that you have your system of equations set up, and I want to see your variables set up, and that's where the majority of your points are going to come from, and then your answer and how you interpret it. So those are the things I'm looking for when I ask you to use your calculator to solve. So if I don't say use your calculator to solve, then that means I want you to solve it by hand, which means use the substitution or elimination method.